Hi everyone, I hope you are well and welcome to the first practical. You've obviously got the step-by-step guide, which I'll just bring into the screen now. And you're welcome to go through this in your own time, but I thought it would be quite good as well for me to um, basically record myself doing this so you can sort of go through and in recording myself I'll probably go into more details that I can do in this step-by-step guide. So you might want to do the step-by-step guide on your own, you might want to just watch my recording on your own, or do a bit of both, whichever helps you. Okay, so in this practical we are going to load in and process a year's worth of tide gauge from the battery point in New York, from NOAA, the National Oceanographic and Atmospheric Administration. I've deliberately chosen 2002 because in October the 30th, Hurricane Sandy generated a very large storm surge which caused quite significant flooding in the Caribbean all along the US East Coast and into New York. And in this practical, we are going to do that. So if I just go to Google here, battery point is this very famous sort of point here, and the tide gauge is situated in a building just off here, so fairly near to the Statue of Liberty. So this is that kind of amazing frontal view that you get. Face. I was hoping to show you that, but I think I've come into the wrong place. But that amazing frontal view you get facing sort of the top of Manhattan. Let's try from here. It might be better. So that sort of view there. So Battery Park is there, and I think the tide gauges are close to this building here. I'm not 100% sure, but I think that's where it is. Okay, so let's make a start. Okay, so the first step is to create folders, and what I've done is I've set up a folder here on my computer called SOES6011 Practicals, and in that I've thought I'd be really organised, and I've set 6 practical folders, one for each. I'm not 100% sure how Ian will do his in 5 and 6, but certainly for my 4. And what I'm going to do as well is within this folder, I'm going to create a new folder called Data, and where I'm going to store my data. I like to keep my data separate, and a folder called Fix. And we're going to work from this Practical1 folder. We're going to copy the data into that. Now you notice that I'm working on a Mac, but it should be exactly the same even if you're working on a PC. Everything should work. Okay, the next thing I'm going to do is obtain the data. Now, in the next 3 practicals, I'll expect you to go online and download the data yourself, but just to help you and to make it easier, because this is the first practical, I will provide the data. And all of the data is on Blackboard. So if we go into Blackboard, let's just log on here. Going to Sea Level Rise Coastal Management. You'll see I haven't quite finished the Blackboard site yet, but it should be finished by the time that you start the course. Go into the practicals, week 1, the data is here. Now, what we're going to do is we're going to download this first site, which is the tide gauge data. So I'm just going to save that. On a Windows machine, it should just save it automatically. You shouldn't have to right-click, but sometimes on a Mac you have to right-click, which is a bit of a pain. Okay, so I'm going to save that to Practical1 data. Okay, and you can see that there's 4 columns of data, but I'll describe that later. And then I'm also going to save this README file to the same folder. So those are the 2 data sets. Now, if you're interested, this data has actually come from NOAA. If you just Google NOAA tides and currents. I've put the link in the step-by-step guide. You can actually download a data set from almost 1,000 tide gauges around the US. If you scroll down, these are the ones that are active. There's historic ones here as well, but if you scroll down to New York, click on the battery. This is the real tide gauge, so you can actually see tide gauges in real time. So at the moment it's in feet because it's American, so the blue is predicted, that the red is what we're actually measuring. You can look at the meteorological data in real time, air temperature, barometric pressure, but the best thing is to go to the station homepage. So here you can see the tide gauge building there. This was established in 1920, so there's actually 100 years of tide gauge data here. We're only going to look at 1 year, but you can see the latitude and longitude, which we will use a bit later. Okay, so now let's go into MATLAB. I should have cleared everything from previously, so I'm just going to clear everything, and I'm going to navigate to the correct folder. So Practical1. So here's my folder, and if you look in data, we should see the data there. Now what I'm going to do is, you can obviously work from the command window as I showed you in the introduction video, but I'm going to always work from scripts. It's just so much easier to work from scripts. I'm going to save this first script as Control1. Now, when people are learning MATLAB, they give these scripts crazy long names. I just find it so much easier to call it Control1, Control2, Control3, Control4, and I'll have a README file later on that tells me what is in each one. And rather than just having one script with lots of code, I much prefer to have have lots of scripts with just sort of break it into different components. Okay, what I always do is I always get into good practice as well and put in comments. And this is really useful because one is if you give this code to someone else, they can understand what's going on. And two is if you haven't used the code for a couple of weeks, you can come back, or even a couple of months later, and it can remind you what's going on. So in order to put a comment, you put a percentage sign. I always put my name, particularly if I'm going to pass this to someone else. I always put the month I wrote this, and then I say this M file. This particular M file is going to load. This M file loads in and plots tide gauge data. I always clear and do CLC. This clears the workspace and it clears the command window. And this is just me being a bit silly, but I always put some characters like this just to break the code up into blocks. Okay, now this first script, Control1, we're going to plot a map of the tide gauge site just to make sure that we've got the tide gauge site in the right place. And what we'll do is, let's go back to the data, and I'm just going to drag this into a text editor. I use BB Edit, but you can use the free text editor. You can use a free text editor on the Mac, or you can use a text editor on Windows as well. So this is what the data looks like. Okay, and I'm going to drag that in here so we can have a look at it. Okay, so we have just some introduction, but the important thing is the lat and long. So let's just have a, let's copy, and so what I typically do is write my code into blocks. Okay, so, and with a block I do a double percentage. So block 1 is input latitude and longitude. And I'll just copy this line across. And what's nice about blocks is you can, rather than running the whole script, anything between 2 double percentages, you can just run that section. And what I'm going to do is I'm just going to copy these lines across here. But I'm going to call this one lat and this one long. Now notice these are in degrees and minutes. And what we ideally want to do is make these into decimal degrees. So what I'll do is I'll take out the north and I'll just divide the 42 by 60 because there's 60 minutes in a degree. I'll put a semicolon on the end so it doesn't write it to the screen, although I can take that off in a minute. And I'll also divide this one by 60. Now, because that was west, this particular value is going to be negative because it's, if it's east, it's positive. If it's west, it's negative. This one is positive because it's north. If it's south, it's negative. So let's just run the code there. And you can see now we have the latitude and longitude correctly inputted there. Okay, the next thing we're going to do is load in a coastline so that we're going to plot it. And as always, you'll see this all the way through my code. I'm going to work in these nice blocks. I'm going to call this load in MATLAB coastline. Okay, I always separate the blocks out. I always number it just because in my head it's clear. Now MATLAB has a built-in coastline, which is quite nice. So we don't have to go and download one. And we can just use the function load coastlines. If I run that, you can see it's loaded in a matrices, a variable called coastlat, which is 9,865 long and coast long. And essentially these are just columns of latitude and longitude, and they essentially mark out the barriers of the world, the coastlines of the world, as we'll see in a minute. Okay, now what I'm going to do next is do a third block of code, and I'm going to call this plot location of tide gauge. Okay, now whenever I do a plot, I first of all need a figure, and I'll just run this section. And by default, it will just be a figure of this size. In subsequent ones, I'll show you how to enlarge this figure and do other things. Okay, now what I'm going to do is I'm going to put hold on. Hold on is important because if I don't put hold on, each plot will be overwritten, and I want to plot two things. So the first thing I'm going to plot is the coastline, and I plot the coast long variable and the coast lat variable, and let's plot these as black. If you look up the help plot function, you can see here, I'll just switch this off, you can see here that you can plot just X and Y, but if you add this third thing called S, you can have a color, you can have symbols, you can have a line, but here I'm going to just plot it as black. I could put that in if I wanted a solid line, but it's going to be a solid line by default. So let's run that, and you can see here it's plotted the coastlines of the world. Now if you zoom in, it's going to be a bit coarse, but nevertheless it's a good starting point rather than having to download our own. Okay, I'm just going to close that down, and then I'm going to plot something second on here. I'm going to plot the lat and long of my point, and I'm going to do a red circle. Now there's additional properties that you can do, which is really nice, but I can make the marker face color as red. If I left that out, it would just be a circular hole. But now I can run this, and you can see that the tide gauge is now in the right location, which is really good. Now to make this plot look a little better, I'm going to add X and Y labels. Now MATLAB is fairly straightforward. If you want to add an X label, there's a function called X label. Now with X label, it always needs quotes because you're inputting a string. If it's square brackets, it's numbers, quotes is a string. So my X label is going to be longitude, my Y label is latitude. Again, I'll run this selection, and you can see it's got longitude, latitude. I'm going to add a couple of other things. I'm going to add a legend. There's two legends here. There's the coastline, let's plug that in, and then there's the tide gauge, the battery tide gauge. Now you can see it's put it. Now I'm actually going to move this to the bottom hand corner where it's sort of out the way a bit, and you can do that by adding a location, and it is north. It is going to be southwest for the bottom hand corner. By default, it's the top corner. Now I'm going to add on a grid. How do you think you do that? Well, it's straightforward. MATLAB has a function called grid. I'm going to put a box on which just kind of puts a nice box around the outside, makes the figure look a little bit better. And I'm also going to add a title. Location of battery tide gauge site. Okay, and there you've done your, for those of you who just started with MATLAB, there's your first plot. And you can see it's kind of got everything that we need on it. Now, it's zoomed into the whole world. So what I thought I would do is just zoom into North America to make it look a little bit nicer. So I'm actually going to add a command here called access. Now, because it's numbers, we need a square bracket here. But I'm going to go from 150 to minus 150 to minus 50. That's the minimum longitude, the minimum latitude. So there's 4 numbers are needed. Then you'd have the minimum latitude, which is going to be 0, and the maximum, which is 80. And now you can see that is zoomed into the case now. Now you can zoom in yourself using these functions here if you want. You could zoom in even more. You can actually just zoom in by scrolling the mouse back and forward. You can also pan. But let's just go back to the original setting here. You can double click on this and edit things yourself, but I don't tend to do that. I prefer to do it from the code. To save a figure, you go File, Save As. I'm going to save it in the figure. I'm going to call this figure 1, and I'm going to save it as a TIFF. Here, by default, it's normally saved a MATLAB figure, but I'm going to save it as a TIFF, which is nice to kind of load into reports. Okay, so that's the first part. I'll stop now, but I'll record 2 more parts where we'll start to plot the data, the tide gauge data next.